folks, I'm back. All right, we're going to talk a little bit about atomic structure. So what I have on the board here is a picture that represents kind of the structure of an atom. So in the center here, you have this region which is called the nucleus. And the nucleus is where the protons and the neutrons live. So in the atom that I have drawn, there are 1, 2, 3 protons and 1, 2, 3 neutrons in the nucleus. The pluses are indicating positively charged protons. No charge here is indicating that these are neutrons. And then the electrons, they reside in these regions outside the nucleus that are referred to as shells. So in this picture, this dashed line represents the inner shell of an electron. You notice I've got 2 electrons in this shell. We'll talk about why that is later. And then here's another shell, right, with another electron out here. So let's talk a little bit about the idea of a shell. The shell is our description of where the electrons live, where they spend most of their time. It's not a surface like you can't come up here and biff it and go, ow. What it is imagine this little electron as it goes round and round and round, leaving like a little paint trail in 3 dimensions. And eventually what would happen is we would end up with this surface painted. And that surface represents the shell. It's the region in space where this electron spends most of its time. It's not an actual hard shell, like you can't biff it. It's just kind of a region in space. Now, one thing about these pictures, and pretty well every other attempt to draw an atom that's very important to understand, is the scale. The scale that I've used here is way, 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 way off. But we have to. You know? We have to draw scales that are not actually appropriate. I'll talk about why. The electron is thousands of times smaller than a proton or a neutron. Probably around, I think it's 3, 4, 5,000 times smaller. So if I were to draw the nucleus the size that I have it, the electrons are tiny, tiny little things. I'd have to like take maybe a pen and dip it in some ink and dot the page with it. And you wouldn't be able to see it, right? So, you know, if the nucleus were actually this size, you wouldn't be able to see the electrons in the video if I were to draw them. So I can't draw them to scale. For that reason, they're blown up. The second huge exaggeration is the orbital size here. These orbitals that I have drawn, or the shell size, are way, way, way underrated. If the nucleus of this atom were actually the size that I've drawn it, roughly the size of a fist, this first shell would not be in the building. Probably wouldn't even be on campus. Might not even be in the Battle Creek area here. Right? The second shell out there certainly is not on campus or anywhere near the Battle Creek area. These shells are astronomically large compared to the nucleus. An analogy I like is, that I read one time, is this, that if the nucleus of an atom were the size of a marble and you put it on second base in, say, Tiger Stadium, you know, the electrons would be in the stands, right, to give you kind of an idea. So these orbitals greatly exaggerated. So, well, I should say greatly under-exaggerated. So here's kind of a picture of a nucleus here, where the positive charge resides. The electrons kind of live in these regions called shells outside the nucleus. These shells are many, many thousands of times bigger than I have them drawn. Again, you know, if this nucleus were this size, this electron would not be in this building or anywhere even close. And atoms have a property called atomic number. And the atomic number of the atom, I wrote this over here, the atomic number is defined as the number of protons that the atom has. So the atom that I have drawn here has an atomic number of 3. Now, you'll notice that it has 3 protons that I drew. Now, also notice that it has a couple of electrons here, one out there, 3, and I drew 3 neutrons. Well, your everyday stereotypical atom typically has the same number of protons, neutrons, and electrons, right? And I say typically, but that can actually vary a little bit, which I'll describe in the next video. But for now, when you look at an atom and you look at its atomic number, that describes how many protons it has, gives you an idea of how many neutrons it has, should tell you how many electrons it has, unless it's missing one or has an extra one. And again, I'm going to address that in the next video. So, the atomic number of an atom, what it really, really defines is this, the number of protons that an atom has. And then it gives you an idea of how many neutrons and electrons it has. The atomic number of an atom is very, very important. The atomic number of an atom is what makes an atom an atom. This atom is lithium because it has an atomic number of 3. If I add another proton to the nucleus, I have a completely different element. Right? The number of protons in the nucleus for any given atom cannot vary. And we'll talk a little bit about the other particles here in the next video.